Okay, problem number 2. I hope you recognize this as being a pretty common problem that we've had before, especially the first 2 parts. A little twist in part 3, part C, a little bit. So they gave you some info about a test and positive, negative test, whether they had the disease or didn't have the disease. So we've done many of these problems. The first question was, what's the probability that the test would be positive when it does not contain HIV? So does not contain HIV is the 526. Positive is does not contain HIV, which is the this 500, and positive is 37 out of 500. 37 out of 500, which is also the number they gave you at the beginning. So 7.4%. If you're grading 1 E, P, and I for that one. Part B says, among the blood samples that had positive results, which ones actually had HIV? So now we're going to the positive results, which is at 526. The ones that had HIV are the 489. So 489 and 526. About 93%, around that a little bit. So again, E, P, and I for that one. 2 pretty straightforward problems, I hope. Very similar to the problems we've had before. Third problem has a little twist to it. It says if the first sample yields a positive result, they want to do it again with a better test to make sure it's really positive. And then they do it 2 more times, and if at least one of those 2 additional ones is positive, then they have to run another more fancy test, basically. So the question is, and they're independent tests, so the question is, if the new blood sample comes to the lab, does not have HIV, what's the probability that we'll have to do that more expensive test? The wording's a little vague here, so I feel like this is a little bit of a trick question because it says if at least one of the 2 additional tests is positive. So a lot of people when they do this say, well, one way to get it is the first test is positive, which we have to have anyways. We have to have that first test positive. Then we do it again. If the second one's positive, in the real world you would never run that third test. At this point you just stop. So there's a little bit of deception in this problem, I think, because I think a lot of people would go plus, 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 or even plus, plus, minus. It's not going to change the answer too much, and it's a very small mistake, but it is a mistake in their context because you have to think about the fact that if this one was positive, you wouldn't do it again. So the only way to get that more expensive test is the first test positive, the second test positive, or first test positive, second test negative, and then we run it again and we get another positive here. So these are the only 2 ways, not plus, 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 and plus, plus, minus also, which I know some people would add. That would give you P if you added that instead of A. So they're all independent. So the 2, we're just going back to this number here. Remember, it did not have it in the first place, so there's a 7.4% chance for each test, right? So for this particular one, plus plus is 7.4% squared, give me this number. And the plus minus plus is 0.074 squared. And then the negative is going to be 1 minus that, or 0.926. So I got those 2 numbers and added them up, got 1.05%. So 3 EPs and I's. I know that's a little bit weird on that one, so I'm going to guess a lot of you probably made that little mistake there. Just kind of the real world context there that you wouldn't run that test that third time if the first 2 were positive.